This one is the first question of exercise 7.3. It's given that ABC is in this figure, ABC and DBC are two isosceles triangle on the same base BC. So BC being the base, so you need to remember that a base is not equal to any side. So that means by default, it's AB is equal to AC and we have BD is equal to CD. That's what the information given here. The vertices A and B, D are on the same side of BC. That is, all of them, both of them is above. Further, AD is extended to meet at intersect BC at point P. Let's find out what we have to prove in the first part. We have to prove triangle ABD is congruent to ACD. ABD, as you can see, this one. This is triangle ABD. First part is very easy. It's congruent to triangle ACD. This one. So you have to prove these two triangles congruent, as it's very clear from the figure only that we have these two triangles can be proved congruent by SSS. I'm taking considering the triangle that is ABD and the other triangle that is triangle ACD. We have AB is equal to AC and even the length BD is equal to CD, and these two informations were given on the question. Further, we know that the length AD and DA are common sides. So we write common. So therefore, these two triangles, that is triangle ABD, will be congruent to the triangle ACD. And clearly this is congruent by SSS. So once the triangle become congruent, let's find out that's the first part, what they're asking in the second part. In this second part, we have to prove triangle ABD, this one. This is triangle ABD. We need to prove this triangle congruent to the other. This time it is this one. These two triangles we have to prove congruent. So when you try to prove these two triangles, you say that you have this information, right? And AP being common, then the third information will be missing. So remember, whenever you have already proved two triangles congruent, try using informations from the previous two triangles. That means their CPCT. That helps you proving these two triangle congruent. What I mean to say that here angle 1 and angle 2 are parts of the triangle that we have proved congruent. So we can say these two sides, these two angles are equal from CPCT. So let's do it. Can use this information. Let's say. Now let's consider these two triangles. This time we have the triangle ABP and the other triangle, it is ACP. In these two triangles, we have AB is equal to AC as given. This is given. And the length AP is equal to AP, and that is common side. So when you write angle 1 is equal to angle 2, so when you'll be writing this angle, that is 1 and 2, make sure you write down the information. Angle 1 is equal to angle 2. You simply write CPCT as it is corresponding parts of congruent triangles. So we can see that now the triangles become congruent. So here the triangle ABP is congruent to triangle ACP. And this is congruent by side angle side, as the angle is included between the two sides. Now, in the third part, we have to prove that AP bisects angle A as well as angle D. That means we have to prove this angle is equal to this angle, that is 1 and 2, which you have already proved, and this being equal to this, that means 3 is equal to 4. Well, since we have already proved angle 1 is equal to angle 2, let's find out how can we prove these two angles as equal. Well, if you see that these two angles belongs to two different triangles, that one is this, another being these. So we'll prove these two triangle congruent. Can prove these two triangle congruent, and we'll be proving this congruent by taking this help of CPCT, that is corresponding parts of congruent triangles. So I'll do it here. So the triangle here, we are, as we discussed, we are considering these two triangles, that is triangle BPD and triangle CPD. We have BD is equal to CD. This is given. We even have DP as common. DP and PD are the common sides. And see, we can write BP is equal to PC. Once again, we can write this length BP is equal to PC, as these are congruent corresponding parts of congruent triangle. You see, we have proved these two triangle congruent, so we can use their corresponding parts being equal in proving the other part. So we simply write that CPCT. So let's write the triangle congruent, that is triangle BPD is congruent to triangle CPD, and is congruent by side angle side. Once the triangle is congruent, we can write this as angle 3 is equal to angle 4. So if you mark this equation as 1 and this as 2, so simply we can write from 1 and 2. That's from 1 and 2, AP bisects angle A as well as angle D. That's the third part of this sum. Later, what we have to prove here, that AP is the perpendicular bisector of BC. So perpendicular means we have to prove that this is 90, or maybe this is 90. Any of them will work. And bisector, that means we have to prove BP is equal to PC. And you see that we have already proved BP is equal to PC. Right. We have already proved BP is equal to PC from CPCT. That means we have to prove these two angles as equal. So let's write this as angle 1. Sorry, you have already taken 1, 2. So we can now use some other. That means I'm taking this angle as, say this is angle 5 and this is angle 6. This is not 90, right? We have to prove this as 90. So what we can do, we can write angle, I'm talking about this being 5 and this being 6. So angle 5 is equal to angle 6. That's from CPCT, as these are corresponding angles of the congruent triangles. Further, we can say that angle 5 and angle 6, they are forming a linear pair as well visible, right? It's forming a straight line, these two angles together. So we can say that their sum is 180 degree. As 5 and 6 are equal, so we can replace 6 with 5 or maybe 5 with 6. So that will give it twice angle 5 is equal to 180 degree. That implies angle 5 is, or say this is angle 5. So angle 5 is equal to 90 degree. Yes. So from this, that is, this angle is 90 degree and BP is equal to PC, as it is proved above. We have already proved that's from CPCT, BP and PC, and this one. From these two, we can say that AP is the perpendicular bisector. You can say that AP is the perpendicular bisector of BC.